Hello, my wonderful students. You're welcome to class today. Still on coordinate geometry, where we are looking at equation of a straight line. Specifically today, we'll be looking at equation of a straight line when 2-point form are given. That is when the coordinates of 2 points are given. And we'll also be learning how to find the angle between two straight lines. I'll be right back. Yes, today we're looking at equation of a line from 2 points when the coordinates of 2 points are given. So let's quickly take an example. Given these 2 points, 3, 2 and 6, 3, we want to find the equation of a straight line. Remember, y equals to mx plus b. That's our equation of a straight line, where m is the gradient or slope and our b is the y-intercept. Y-intercept is simply where the straight line crosses the y-axis. That is our b. Mx plus b. Now to find our gradients, that's the formula y2 minus y1 over x2 minus x1, which is also known as slope. Now let's tag each of our coordinates x1, y1, x2, y2. Of course, we'll call the first point 1 and the second point 2. So x1, y1 and the second point x2, y2. So we quickly substitute to obtain gradient first. The first thing we do in finding equation of a straight line when 2 points form are given is to obtain the gradient. So what's the value of our y2? Our y2 is 3. Then our y1 minus 2. Our x2 is 6 minus 3, which is our x1. So if I simplify, I have 1 over 3. Good. That's our gradient or slope. M is equal to 1 over 3. That is what we just obtained. Now, how do we find our b, which is the y-intercepts? According to that formula, we want to find b. We can make use of either of the 2 points given to represent our y and x in that equation. Remember, we already know our m, 1 over 3. So we only make use of any one we like, any of the points, and we are going to get the same answer for our b. So let's make use of 6, 3, the second point. Our y is 3, our x is 6. So we substitute gradient 1 over 3 times 6 plus b. So simplifying that, 1/3 times 6 gives us a 2. Gives us a 2 plus b. So if I multiply 1/3 times 6, I have a 2 plus b. So if I simplify that, if I solve that equation, that's going to be removing 2 from both sides. So my b is 1. So b is equal to 1. Good. So I've gotten the equation of a straight line in y-intercept form. So the answer is going to be y equals to 1/3 x plus 1. Y equals to 1/3 x plus 1. That's our answer. So we'll be looking at a second one now. That second one will go a little bit faster than this one. Good. We want to still determine equation of a line. Given that the 2 points are minus 2, 3 and 8, 8, 0.1 and 0.2. The same y equals to mx plus b. M gradient or slope, b y-intercept. So let's get the values of our points. x1, y1, and 8, 8 will be our x2, y2. Good. So let's substitute y2, 8, and my y1 is 3. Let's substitute them one after the other. 8 minus 3. We have labeled all the points. Our x2 is 8 and my x1 is what? Minus 2. X2 minus x1. That will be at the denominator 8 minus 2. Good. And that's going to give us 8 plus 2 at the denominator. That's 10. So we have 5 over 10 as our gradient, which is 1 over 2, reducing that to lowest term. So my gradient or slope is 1 over 2, as we can see displayed on the screen. So the next thing is to find our b. How do we obtain the value of our b? Remember, like we did before, we could use either of the 2 points. Gradient is m is half, so we are making use of that first point now. To why my y is 3 and my x is minus 2. So 3 equals to half times minus 2 plus b. So if I multiply that, that gives me 3 equals to what? Minus 1. Minus 1 plus b. So if I solve that equation, my b is going to give me 4 by adding 1 to both sides. Okay, my b is 4. Y-intercept is 4. So what is going to be our equation of a straight line in y-intercept form? In y-intercept form. So y is going to be half x plus 4. Good. So that is the equation of a straight line for this second one. Let's look at when two straight lines are parallel and perpendicular. Parallel lines. We can see two parallel lines. What's the condition if the first gradient is m1 and the second one is m2? When two lines are parallel, their gradients are said to be equal. In case you are given one gradient and you have to find the other parallel line, the gradient of the other parallel line, they are meant to be equal. m1 is equal to m2. Let's look at the condition for perpendicular line. Condition for perpendicular line. When the two lines are perpendicular, the product of their gradient is equal to 1, minus 1 rather. The product is equal to minus 1. That's the valid condition for two lines to be perpendicular. So if I know one gradient, I can easily find the other gradient. Very good. Yeah, so we have learned something about parallel lines and angle between two lines. When two lines are given and their gradients are known, we can find the angle between the two lines. So the tan theta is m1 minus m2 over 1 plus m1 m2. All we just need to do is substitute our gradients. M, remember m are the slopes or gradients. Once you substitute them, you'll be able to find the angle between the two lines. Okay, this is the diagram depicting two lines. The blue line and the green lines are the two straight lines, and the angle between them is theta. The angle between them is theta. So to find the angle between the two lines again, we could say m2 minus m1 over 1 plus m1 times m2. Now notice something, that there's an angle between the x-axis and the straight line. For the blue one is alpha. We can also use that angle to find the gradient of that line. So M1 is tan alpha. So tan alpha is an alternative method of finding gradient of a straight line. Now if you look at the green line, there's an angle between the positive x-axis and that green line, which is beta. We can use that angle beta to find the gradient of the green line, which is M2 equals to tan beta. Good. So all this one are just to buttress what you have learned before and to ensure that you have really learned them.
Yes, you're welcome back. I hope we enjoyed the class. And today we have been able to learn the 2-point form of a straight line equation of a straight line when 2-point form are given an angle between two straight lines. I hope you had a wonderful time with today's class. Till we meet again, make sure you're a good student and pay attention to your studies. Thank you. I'll see you later.